So this article is related to distributed predictive energy control and smart grids using network consensus mechanisms in MATLAB. So in this paper, basically we have just presented the consensus-based distributed network predicted control (DMPC) framework for large-scale smart grid energy management, and it also proposed the thousands of interconnected nodes to cooperatively regulate their energy states while respecting local dynamics and shared network objectives. Each node solves a local predictive control problem and iteratively exchanges information with the neighboring nodes using a Laplacian-based consensus mechanism. So the main thing is that the gradient-based optimization strategy is employed to ensure the computational efficiency and scalability for high-dimensional systems. So the distributed formulation significance reduces the communication and computation burdens compared to the MPC. Okay, so here is the keywords with the introduction. In the introduction, I have written the average energy levels versus reference and the average control input for the DMPC simulation outcomes for smart grid. And the smart grid, we have to monitor the energy distribution across the nodes, and we also need to distribute the error over time, and we also monitor the energy level, which is the average energy performance and energy generation accordingly. So here is next is consensus-based coordination. Basically, mechanism play a very important role in local decisions with global objectives in network systems, and distributed predictive control method enables a large-scale system to be controlled efficiently by decomposing the global objectives. Okay, so here is a background and motivation. In the background and motivation, we called it traditional centralized control architecture struggle to handle the scale and complexity of such systems, and the number of nodes increasing, communication overheaded, and computational burden grow rapidly. So that's why we have used the distributed control enables the local decision making while maintaining the overall system objectives. Okay, so this is the role of distributed model predictive control. Basically, this is the technique used to gained considerable attention as an effective solution for the large-scale network system. So consensus and cooperation mechanism enable the synchronization and coordination among the interconnected agents in complex networks. So here is the system model parameters in terms of state transition coefficient and different control input coefficient, energy state of node, control input reference energy levels as well, consensus based coordination for the smart grid as well. This is the challenges and contribution, and the problem statement also I explained very well. The mathematical approach. In the mathematical approach, I have just added how the linear model is added using in MATLAB, and only neighbor-to-neighbor communication is required, and ensuring the scalability synchronization of the cooperative system can be achieved through the optimal control designs incorporating state and output feedback as well. Here is the methodology. In the methodology, I have just used the communication network parameters and the design MATLAB simulation here, which is the simulation parameters which used I have in MATLAB. And this is the output graph of average energy level versus reference, and this is the average control input graph. This is the energy levels for first 10 nodes, and next one is the control inputs of first 10 nodes control inputs, and this is a consensus over error over time, and the final energy distribution across the nodes histogram basically provide us, and this is the actual results in terms of performance metrics, and then write conclusion and future works as well as the references. Let me just show you the MATLAB demonstration in terms of distributed productive energy model predictive control for smart grids. This one, okay. You just need to run this section and you will get the output results accordingly. Simulation loop is designed track consensus error. Okay, so these are the 6 figures in terms of consensus error over time, control inputs for 10 nodes, energy levels for 10 nodes, average control input, and the average energy level versus references. Okay. If you need to ask anything, you just ask me, I will answer your questions. Thank you.